Okay. طيب بسم الله الحمد لله والصلاة والسلام على رسول الله. I would like to welcome you all for this course EE467, which is Power System Planning and Operation. In this course, we will discuss several problems in power system, which could be on daily basis or hourly basis or even minutely basis. Some problems will be fall under planning problems and the other under operation problems. And we may have also some problems which called operational planning. And you have to plan for 1 hour coming. So this is during the operation of the system, you need to plan for the next few hours or so. So these problems are called operational planning problems. At the beginning, let me
Doctor.
Yes.
Some students find difficulty to join us.
Why?
I don't know. They said they can't find the course.
They can't find the course?
Yes.
Maybe they joined late. They registered the course late, so their names are not appearing in the list. Let me stop sharing at the beginning here. And okay, so let us go for, I don't know how I can add them now in the Microsoft Teams, but if I know their ID. Yeah, here it is. Ahmed Fahd Abdul class on 30. Muhammad Hassan, yes. So how can I know their IDs of Ishaq? Maybe
I asked some to send the ID. Can I give you?
Okay. Put them in chat.
Okay.
Or put them in the posts here, if you want.
Assalamu alaikum, I just joined.
Okay, welcome. So give me their ID if possible. It's
2016.
2016.
529.
529.
80.
80. Ryan Hadib.
Yes.
He just registered the course or what?
I don't know.
Okay, now he can join. Or anybody else?
Yes, one another.
Okay.
2016.
2016.
79860.
79860. 79860. Malik Ali Hassan.
Yes.
We add also Malik Ali Hassan. Anyone else?
No, that's it.
Okay, great. I think we have 31 now. Of course. So let us see whether we have still somebody to join. Muhammad Ali bin Isa, more 3. Okay, I don't know. Okay, we have 28 currently attending, but we have more 3. Come on, I mean, we have also 3 to join. So let me check this whether we have anything in Blackboard or emails. The code of yes, here we have Baqir. The code that you have sent us is not working. I don't know if I'm the only one having this. Did we add Baqir? Baqir Abdulaziz? Is he around? Baqir Abdulaziz are attending? I saw your other message. I haven't been added to Teams. Okay, please. Me. Need to add. Malik is attending now.
Yes, yes.
Okay, great. So we have Baqir only. I send him to send me his ID to add him. Just 1 minute to sort it out. Abdulaziz is with us now. Abdulaziz Said.
Yes, doctor.
Okay. Ryan. Just go to edit. Okay, thank you.
Yes, Doctor, I'm here.
Great. So Baqir, he sent me his email. So let me add him. Zero 16 3939. Baqir. Right. Bakar now is attending. Yeah. Right?
Yes,
Okay.
I'm here.
Okay, great. So we can start now. Let me share again. This way. Okay. So this course is power system planning and operation. As you mentioned, we have dozens of power system problems. We can categorize them to planning problems, operational problems, or in between operational planning problems. We will discuss like 6 or 7 problems that related to planning or operation or operational planning. So let me at the beginning introduce myself. This is the course introduction. Let me stop sharing. Let me share first the class introduction. So we can discuss first the class introduction, just to make sure and everything is here. This way. So this is class introduction. Did you see the? Do you see my?
You can see the PowerPoint, Doctor.
Yes, the PowerPoint, the slides.
Course introduction or class introduction?
Class introduction.
Now it is class introduction. Okay.
Yes.
This was this. Okay, so let me introduce myself. And at the beginning, طبعا the name, as you can see, and the office. Of course, we are not, going to the office these days. But if, and after this period of 7 weeks, we go back to the face-to-face classes, then this is my office, and this is the office telephone, and this is my email. So you can, you can communicate through the email, as you can see. Office hours, of course, for the face-to-face office hours, this would be Monday, Wednesday, 11 to 11:50. But these days, this will not be activated. So we will communicate through the appointment. You can send me an email, or I can, if you prefer, let me take your opinion of having virtual office hours during the day or or at night. So let me seek your opinion if you have a problem with the hours at night. and 9. Can I collect your responses for this just survey question? Do you see it?
We
No,
see
not yet.
instructor of SOAR and formation.
No, that's an instructor of that. And I asked you, do you prefer office hour at night?
No, we can't see it.
We can see it.
In the posts. Can you go back to the posts? Can you go back to the posts?
Doctor, we can't change the slides. You are the only one
Yes,
who can.
doctor, I can't see it. I can't see.
In posts, you go to general.
I can see it, doctor.
You go to general.
You go back to the
doctor. I
chat
see
and
it.
you can see it.
General, yes.
Okay. So please, now we need like 30, 31 or 32.
So what do you
responses.
mean by go back to see it?
Go to general, you know, the course, if you go to Teams, you will see the course, and then general, when you see the posts.
Yeah, I see it now.
Okay.
Most of us prefer night officer.
Still need more than, or like 9 responses, yani most. Suppose yani you have 32 or 31 participants. So the majority goes to the office hour at night. Okay. You see the responses.
Yes, doctor.
Yes.
Yes, we can see it.
Yes.
Okay, so let us fix office hour at night. At the time being, at least for these 7 weeks of online classes. So, and I hope those responded no, they can communicate through the email, so we can set any time they would prefer. We can have if it is not any convenient for some of you. So I will send you the details, and I think we can do the office hour also in the in Microsoft Teams. And I will from 9 to 10 p.m. I will specify 2 slots, like Monday and Wednesday also at night, and I will open the course and I will open the meeting, and then whoever has a question or so, he can join and he can we can chat, or we can discuss whatever he wants. Okay.
Okay.
Okay. طيب, inshallah, we will see this point. Just a brief bio of the instructors. I got my BS and MS from Nufia University, Egypt. and I joined the King Fahd University last century, and I got my PhD from KFUBM, and I'm currently professor in the department. My area of interest is usually power system control, operation, renewable energy, intelligent control application to power system, and also optimization techniques applied to power systems. So let us see briefly the course coverage and objectives and the grading policy, and also the class regulations and so on, and then we can go to the just introduction to the course. So what are the power system planning problems? Do you have any idea about the planning problems in power systems? Please, if you have, you can answer. Unmute yourself and answer if you have. Or you can raise your hand, and then I can see, and I can ask you to answer. What kind of planning problems we will discuss in this course? What do you think? And which problem that you can say, no, this is a planning problem? You have to plan in advance. You have to find the solution maybe 1 year, 2 years, or maybe you can have like 30 years. You have to prepare yourself from now. So Ali Said.
I think the first problem that we need to decide the location of the power station.
Exactly, you are absolutely right. This is called the generation expansion problem. You have to plan for 5 years, 10 years, for 20 years from now, where the possible locations of generation plants, and in this case you have to take into consideration the population, the governmental plan for industrial cities, or cities, and so on. So this is one problem.
If we have several machines, we see whether it's worth it to get rid of one of them or install a new machine to the system.
Yes, you are right. This is also related to what we just discussed, the generation expansion. Okay, of course, for example, the lifespan for each power plant 25 years or 30 years. So you can say, within the coming 5 years, I have to retire some of the generation plants and I have to replace them with the new plants. So this is generation expansion problem. Abdullah Abdul Karim.
Yes, Doctor.
Yes.
Wanted to mention the capacity or the demand of load and how can we mitigate that into the system. This is one thing that we have to plan for, and we have to expect what's the demand in 20 years, so the infrastructure would suit that.
You are absolutely right. This is called demand forecasting or load forecasting. Okay, so load forecasting can be divided to 2 categories or 3 categories. Long-term forecasting, you are talking about 30 years from now. You expect how much your load, and in this case, you have to plan for this. Or short-term load forecasting, you expect or you forecast your load within coming few hours or tomorrow or this week. So you have the hourly loading within this week, and you have to plan for this. So this is called load forecasting problem, and load forecasting problem also is a planning problem. And you are absolutely right, load forecasting and generation expansion planning. What else? Abdullah, Abdul Karim, you maybe you lower. Okay, Abdullah, Abdul Karim, you still have, you are raising your hand. Do you have anything else, Abdullah? طيب صالح Abdullah?
Maybe environmental standards and financial ability, reliability.
Okay, so you are also right. You can have what we call the transmission expansion planning. You have to design new transmission lines. You have to enhance the existing capacity of your transmission system in order to improve the reliability of your system. If one transmission line is out of the surface, then you can still supply your loads without any interruption. So you can increase your reliability of the power system. So this is okay. This is for planning problems. So what do you think the operation problems? What kind of operation problems that we have during the operation of the power system? You have to solve some problems. Hadi, Ali?
Maybe the type of controller you need to control the generation of electricity or to control the frequency that you are generating.
You are absolutely right. So control problems, you have to control your frequency. Frequency should be maintained at 60 hertz, and you have to have control on synchronous machines or turbines. If you have thermal plants or gas plants, you have to control the turbine, the speed of the turbine, so to keep the frequency to 60 hertz. You are right. This is, we call it automatic generation control problem, and this is operational problem. What else? Malik Ali?
Maybe the maintenance and security toward the power plant or even the distribution system.
Maintenance. So you took us back to the planning problems. Maintenance is you have to prepare the maintenance in advance, right? So this is maintenance is a planning problem. You cannot take one equipment for maintenance while it is in operation. You have to plan for this earlier. So maintenance is a planning problem, right? For example, you have to prepare the maintenance planning for the power plants. You can say, no, okay, and the load in winter is light load compared to summer. You have low load in winter, right? So let us take this power plant coming February, for example, for maintenance. So you have to plan for the whole your plants that needs to be maintained in advance. So maintenance is a planning problem. Okay, next, Ahmed Fahd.
I think, Doctor, the losses in the transmission line, and also maybe if I raise the voltage here, I will have more losses. So I think it's an operational problems.
Yeah, exactly, it is an operation problem. As we mentioned, the frequency should be maintained to 60 hertz. You need also to maintain the voltage at the rated voltage. If it is like 230 kilovolt or 380 kilovolt in transmission levels, 69 kilovolt, sub-transmission 33 kilovolt, 11 kilovolt, or 4.16 kilovolt, 480 volt or 230 volt. All these volts should be maintained at the rated. You can allow, of course, for plus minus 5% tolerance, but you have to take an action. You have to control the voltage to be kept within these bounds from, let us say, I don't know, did you cover the per unit quantities?
No.
Okay. So maybe maybe I have to give you an introduction to per unit quantities, but later on, inshallah, at the beginning. Okay. So yes, voltage control is, and also minimize the losses. You need to switch some capacitor banks. You need to play with reactive power, power flow, reactive power flow in the transmission lines in order to keep the voltage and to minimize the losses. Okay, this is great. This is an operational problem. Ahmed Fahd, you still have something, or you?
No, that's it.
So please lower your hand.
Doctor.
Ali Muhammad. Ali Muhammad.
Yes.
Yes, please.
Some problems would be the electrical surges, the high electrical surges, like those coming from lightning. Those problems could cause faults in the continuing operation for like motors and other electrical devices.
Yeah. You are talking about protection system.
Yes.
Right? So protection, of course, this is also an operational problem. You have to protect your equipment from lightning, from faults, from any disturbance in the system. You have to make sure your equipment are protected and everything is fine in order to, of course, not to burn any motor or any transformer, and this will cost you a lot, millions of dollars. So do you have anything else, or you need to lower your hand, please?
Doctor, I have an issue.
Yes, doctor.
Saleh Abdullah?
Yes, voltage stability in distribution network. Maybe one of the...
Voltage?
Stability.
Voltage
in distribution. Yeah, in distribution network.
Okay, you are right. This is also an operational planning. To keep the voltage anyway, and whether in transmission or in distribution, this is an operational problem. You have to know what are the tools that you can play with, or the power system operator can play with in order to adjust the voltage. Whether you have transformer, tapping of the transformer, this is one. You can have some switchable capacitors or capacitor banks, so you can switch on off some of the capacitor bands in order to keep the voltage within the bound. Okay, great. So we cover a lot of operational problems. Of course, there are some other problems in the stability of the system. If you have any disturbance, you have to keep your system in synchronism, and the machines should be in synchronism with each other. And also voltage stability, as you mentioned, and reactive power, security, and so on. We will cover some of these planning and operation problems in this course. So,
Doctor, I have a question.
Yeah, please, if you have any question in general, if you have any question, please interrupt me, raise your hand, and then we can discuss. Yes, please, go ahead.
I have an issue. You put me as an organization and as an organizer, so I cannot raise my hand. If you could remove me from organizer.
Yeah, you are the organizer now?
Yes, so I cannot raise my hand.
And I don't know how to make. لا أنا now I'm يعني just attending the please okay يعني it's good to raise this point. Please, when you don't start the meeting yourself, okay? And probably you came first, and then you start the meeting, and then we join the meeting. So you are becoming the organizer.
So you cannot remove me from as an organizer right now.
لا, I don't have the control now. You have the full control now. And by the way, you can remove me.
Oh yes, I can. And yes, I have all the control. So I leave and I left and I joined again, but it's not working.
So please, in general, so Muhammad Hassan Ali, you are the organizer now.
Yes.
Let me check mute participant. I don't have any control on this. So please, in general, don't start the meeting. Okay?
Okay.
If you open the Microsoft Teams, stay there. Don't start the meeting until I start it. Now I couldn't do any, I don't have any control.
Doctor?
Yes.
Why we are not moving to Zoom? That's better.
والله يعني Zoom I'm يعني happy also with Zoom. I don't have any problem. But here you have some features that's not there. يعني surveys, quizzes. Yes, you have some features here better than, and your names here are added directly through the university. So I don't know, يعني I have no problem, but the university recommends either Blackboard Ultra, Collaborate Ultra, or the Microsoft Teams. So I feel Microsoft Teams is better. So this is why we start here with the Microsoft Teams. Of course, we can, I have no problem, but the problem now is when you go to the Teams and you start, now I don't have any control, Muhammad Hassan Ali.
Yes.
Okay, so حتى even now the features or the features of the owner of the course, which is myself, I don't have any control now on this. And I don't know whether we should close this session and I start it again or what. Please don't start the meeting before the instructor. The instructor should start the meeting in order to have full control on this.
I think that the organizer can change the organizer.
The organizer, he is not the owner of the course, so he cannot do much. Even Muhammad Hassan,
Yes, Doctor.
If you press the 3 dots next to your name here.
Yes, I press it, and there is mute participant, then remove participant, make an attending. These are the options that are appearing.
I don't know. So what should we do now?
We generate a new one.
Maybe Mohammed, if he clicked on your name, he can make you an organizer again.
No, I don't think so. حتى ماجد الفاروق ماجد الفاروق.
Yes.
You start recording, and also again, and I should record and I will record. And when I started the meeting, I will record it, and I will make the recording available. It will be available in the course page here, and I can even download it from here and upload it in Blackboard, so you can visit it any time you want. So please, and I will record. I will start the meeting, and I will record it. Yani don't start the meeting, don't record it by yourself. Okay. طيب علوم يعني since this is the first time and we will not do any يعني any just introduction to the course and so on. So we will continue in order to be more convenient rather than switching off and logging in again. So let us continue, and please take care of these 2 points as we mentioned. Don't start the meeting. If you open first, then keep quiet until I log in and start the meeting. And also for the recording, I will record the meetings and make it available for you later on. Okay? Okay, so let us continue. So the course concerns the basics of power system planning and operation. Short and long-term demand forecasting will be discussed. Power generation cost, economic dispatch. This is another operational planning problem. Economic dispatch and the unit commitment will be discussed. The economic dispatch is if you have a load of, for example, 100 megawatt, and you have 5 generation plants are on, how to distribute this load among the power plants? Are you going to dispatch them or distribute them equally, or what? So this is the economic dispatch problem. Unit commitment problem, what are the units should be on to carry the load? What are the units should be off at this time, and so on? This is called the unit commitment problem. We will discuss this problem briefly in a few minutes. Power system security. Would be the system secure? Any overloading, any over voltage, under voltage? Do you have any problem? If you don't have any problem, then the system will be secure. Even if you remove 1 generation plants, 1 transmission line suddenly tripped or disconnected, your system is still secure. No violation of the limits of the transmission line. Transmission line of, for example, this transmission line between Dammam and Riyadh, this link could carry up to 1,000 megawatt. So if we have any disturbance, if you have any generation plant out or in, or something happens suddenly, would be the power flow through this line exceeds the limit more than 1000, you have a problem. If it becomes more than 1000, you have a problem and you have to solve it. You have a problem, that means your system is unsecure. So you have to do an appropriate action first and the appropriate action to remove this problem. The optimal power flow is also, we will discuss it, real power flow and reactive power flow, state estimation. State estimation, you need to monitor your transmission line. You can, with some measuring instruments, can you estimate voltage and the angles at each bus in your system, so you can see whether you have over voltage or under voltage, or if you have any problem. So this is called the state estimation. And the automatic generation, as we mentioned, to keep the frequency at 60 hertz, you have to adjust the power output of your generation plants. Along with these problems, we will expose you to some of the optimization concepts. And as you mentioned, these problems are optimization problems. You need to forecast your load and minimize the error. You need to minimize the error of forecasting between the actual demand and the forecasted demand. You need to distribute the load economically. You need to minimize your cost. You need to increase the security, or maximize the security. So it is an optimization problem. For optimal power flow, you need to minimize the cost of the generation. This is also an optimization problem. In the state estimation, you need to minimize the error between the estimated value and the actual value. This is an optimization problem. In automatic generation control, you need to minimize the deviation of the frequency from 60 hertz. This is also an optimization problem. So the optimization problem or optimization concepts will be, through all these problems as we will go on. The course objective, of course, we need to expose you to some planning, operation, and the control and the management aspects of the power system. We need to equip the participants with advanced state-of-the-art knowledge and the skills in solving power system planning and operation problems, the techniques. If you need to forecast the load, what are the forecasting techniques to do this? What are the optimization techniques to solve these problems? So these are the techniques and the skills needed to solve these problems. We need also to enhance the participants' knowledge in theoretical and the practical aspects of power system planning and operation. From time to time, as I would like to share my experience also for real life problems and how they address it in utilities in Saudi Electricity Company. How did they do for load forecasting, for economic dispatch, for this and that. So we will, from time to time, we will expose you also to some practical issues in real life. So the outcomes, hopefully by the end of the course, you will have the knowledge and the skills to real world power system problems, and you will be able to formulate these problems, load forecasting, economic dispatch, and so on, and also to analyze and optimize these optimization problems for planning and operation. The textbook, there is no textbook on for this course, unfortunately, but this book is very good in power system operation and control, power generation operation and control, by Alan Ward and Bruce Wallenberg. This is, you can search, you can download it from here or there. Other references, the power system analysis. This is a very good book also. And bar system analysis also, that's 463.
Yeah, 463.
Yeah, this is 463 textbook. You will have some of the problems that we are addressing here. You can find them there, like economic dispatch, optimal power flow, automatic generation. Such problems you can find them in bar system analysis book. So, in addition to this, we have the notes or the slides, and also from time to time I will share with you some notes if time or if available. So these are the things. The course breakdown, first week will be introduction to of basic concepts. Electric load forecasting you will start in the week 2 and 3. Then we will see the economic dispatch problem, then unit commitment problem, and bar system security problem, and then we will see the optimal power flow, bar system state estimation, and automatic generation control. And then last week will be for review and the project presentations. So the grading policy, I would like to see if anybody raises hand. Okay. The grading policy, we have assignments, we have quizzes, we have attendance. This will be like 35%. طبعا expect a quiz every week, and this quiz will be either through the Teams or the Blackboard, regular Blackboard. You can have a quiz there. We will announce, of course, for the quiz. The major exam will be 15% the weight, and then this would be week number 9. By the end of the week number 9, and hopefully this exam will be face-to-face basis. Hopefully we can come back to the normal at this period, or at this time. In projects, we have 25% of the projects. We have 2 projects, one of the literature survey or reading assignment project. So you can take, we will announce the topics that you can select from, and you can prepare like a report and the presentation of this topic, and also some design projects later on could be on load forecasting, economic dispatch, could be in any other problems that we will discuss. The final exam will be 25% will be comprehensive, inshallah, and this is as will be scheduled by the registrar. And attendance is very important, of course. The attendance could have 5%. The quizzes could be 15%. The assignment also could be 15%. This is a tentative distribution. During the class, we will ask you to solve like short quiz. This will be considered also in addition to the other type of quizzes on Blackboard. The assignments, homeworks, and so on also will be considered. So 35%, 5 for attendance, and 30 for the assignments and the quizzes. Tentative schedule 15-15. If you have 6 absences, then you have the end grade in the course. Try to attend, and I will collect the attendance here through the Teams, and it gives me at the end an Excel sheet with all the activities. If you log the time you log in and the time you left, and if you connect back and so on, so everything is recorded here, and we will see. Of course, 10 minutes late, this will be also considered as absence. So be careful, you have to at the proper time. Two activities, as we mentioned, and we have reading assignment, which you will pick a topic and then you do some literature survey on it, and the other term project, which is like planning a problem or operation problem you will design. Participation is very important during the class. Please try to be alert, try to participate, answer the questions raised. If you have any question, please raise your hand and ask me to repeat. If something is not clear, I would appreciate this. This is very highly appreciated. And again, to ask me to repeat again, or in order to, deliver it in different ways so the people can, understand well. You are encouraged to ask me to clarify any part at any time. Just in order to, make it organized, raise your hand and then I can, ask you to unmute yourself and then you can ask. You should be alert to answer questions I raise in class. Also, don't be away. You can log in and then you left physically, but you attend virtually. This also is not recommended. I will ask you to for any input, and based on this input, I can know who respond or he is not responding. He is away from the screen or from the class. So be careful, and this also will be considered for the absence issues. Please interrupt me with questions and or comments if you have. Blackboard supplementary material, assignments, announcements, communication will be posted through the Blackboard. The students are advised to check the Blackboard on a regular basis, of course, for any announcement for so. Class regulation, the attendance will be collected at the beginning and at the end also, not only beginning, but at the end as well. And as I mentioned, at the end of the class, the report will give me all the names in Excel sheet. So more than 10 minutes late, you will be considered absent. During the class, there will be several online activities. If you miss any, you will be considered absent as I mentioned. This is the class introduction. So if you have any comment or if you need something, so please let me know.
Doctor?
Yes, please.
Regarding the exams, will be on the Blackboard or we
Blackboard.
come to the... Oh, okay.
Most likely, Blackboard is better in quizzes, long quizzes, and then exams will be through the Blackboard, inshallah.
Okay.
Malik Ali Hassan.
Yes. Can you post the lectures in advance so we can review them before the class?
I will do, inshallah. I will do you prefer, this is for all, do you prefer to be posted in Blackboard or here in Teams?
Blackboard is
I
better.
think Blackboard is better.
Blackboard, Doctor.
Blackboard.
Blackboard is okay.
Yes.
Okay. Great. So any other comment or question? That's great. Let me end this show and go to the another course introduction. You see now course introduction.
Yes, doctor.
Yes.
Yes.
So any this is just a brief introduction to the course in order to give you a clear picture, complete picture about the course, about the problems to be addressed, and how these problems are related to each other. So we will discuss like 6-7 operation and the planning problems, and we will clarify the link between these problems. And for example, let us see the and I would like let us go to forms again, and I will give you this forms. Go to the general, and I will ask you a question now. Did you take EE463? Yes, no. So please give me your response. Why not comes first? Please quickly. It shouldn't nothing to be think about. So we have only 24 responses, 25. That means we have 6-7 of you are not there, are not with us now. So you have 26 now, or 26 responses. And where are the remaining? 6 students are not there. Okay, so and it's clear now. But okay, so in this case,
Doctor.
Yes.
So this course depends on 463.
We will not make it depending on 463. Whatever we need from 463, we will we will discuss it briefly here. And maybe very unit quantities. This is important point. So we will give you a brief introduction about the very unit quantities. But of course, if you take 463, this would give you some other problems, which is the load flow problem, and also the fault studies and the stability problem. So you are familiar with other problems of the 463, which gives you like a background. But anyway, the course could be independent from 463. Of course, 463 is not a prerequisite for that course. So that means this course can be a standalone course. Okay, so we will make it independent of 463. Don't worry.
What about 380, Doctor?
380, and at the end of the course, as we mentioned, we have automatic generation control problem. Very basic issues in control theory in 380. In 380, we need it here like a block diagram, like block diagram mainly, which is also could be, definitely most of you covered 380, isn't it? And should we do another?
No, I didn't.
Definitely, all of you almost, they already take 380. You are a senior level students, right?
No, I didn't take it, Doctor. I didn't take 380.
Is it currently taken?
Yes.
خلاص when we reach to this problem, automatic differential control, you will cover the basic elements of the 380. So don't worry. Everything will be in order, inshallah. Okay. So bar system planning and operation course. As we mentioned, we can categorize the problems to 3 problems: planning problems, and we can have under the planning, we can have long-term load forecasting, generation expansion planning. You need to find the location and size of the generation plants for the coming 30 years from now. Transmission expansion, you need to know also the capacity and the path of the transmission lines to be installed for the coming 30 years or 25 years. So the transmission expansion, maintenance scheduling also for the coming year or for the coming few years or for the coming month. You need also to find the schedule of the plants or the equipment, transformers, transmission lines for maintenance. So you have to prepare this in advance. So this is the planning problem. The other type is operational planning. And while you are operating the power system, you need to also do some planning problems during the operation. Short-term load forecasting. You have to forecast the load for the coming hour, for the coming few hours, for this week. And 7 days from now, you need to, within 7 days, you have 168 hours. So you need to predict your load for 168 hours ahead in order to plan your system, which machines or which plants should be on, which plants should be off, what should be the load, and so on. Unit commitment, again, plants on and off. You have to also plan this. The economic dispatch, and you solve this unit commitment problem in order to find out what are the plants that should be committed, should be on to cover your forecasted load. So you forecast the load at the beginning, you find the load at 100 megawatt or megavolt ampere. So what are the units should be on to cover this load? This is the unit commitment problem. If you solve the unit commitment problem, we have 3 generators, generator 1, 2, 3. So these generators should be on in order to cover the load. How to distribute the load among these 3 generators comes from here. So this is the economic dispatch problem. You have to solve the economic dispatch problem. Are you going to distribute the load equally among the generators, or you have to consider some other issues in order to minimize? When we say economic, that means you need to minimize the cost, the operation cost or the operating cost or the generation cost, which fuels, which machine will be more efficient, so you can add the load more to those machine. If the machine is not efficient, so you reduce the load in order to have minimize or in order to have the minimum generation cost. So you solve economic dispatch problem. So at the beginning, you forecast the load, you do unit commitment problem to get the machines should be committed, and then you distribute your load among them. The other type of problems is the operation problem. As we mentioned, you have automatic generation control. You need to adjust the frequency to 60 Hertz. You need to make sure the generation cost is minimal, and also the reactive power flow or losses is minimal, and so on. System is secure. There is no overloading. There is no over voltage. There is no under voltage. Everything within the order, and you have the full control or full observability. We say observability problem. The power system operator can observe all the states of the states. Here means voltage, magnitude, and angle. Then, as you know from the nodal analysis in 202, if you have a network, and if you know the voltage at each node, you can completely analyze your network, isn't it? This is a nodal analysis.
Yes, yes, doctor.
If you know the voltage at each node, in this case, you can find the current through each line. You can calculate the generation. You can calculate the losses. You can completely analyze your network. So we need to estimate the voltage at each bus or at each node of the power system in order to observe all the line flows and voltage at each bus. So basically, in our course, we will cover the operational planning and the operation problems. We will cover short-term load forecasting. We will cover the unit commitment, economic dispatch, and these 4 problems of operation. What is the load forecasting? The time is over. The time is over. So I think we should stop at this point and continue next class, inshallah. And as I mentioned, I would like to remind you, don't start the meeting, please. And don't record the meeting. I will record it and make it available, and I will start the meeting to have full control on it in taking the attendance and download the Excel sheets for them from the responses of the. If you start the session, I will close it. And I will start another one, and you have to switch from this to that. This will be inconvenient. So we didn't do this today. We don't have anything, just an introduction. But later, please don't start the meeting. Okay?
Okay, Doctor.
Yes, please.
The attendance for today, we will have attendance or not?
The attendance for today, this is another issue. Who's the organizer? Who's the organizer?
Yes. Muhammad Al-Khalaf.
طيب, Muhammad.
Yes.
If you press on the participants, do you see the names of the participants?
Yes, I can.
طيب, next to the people at the top, next to the people.
Yes.
Do you have 3 dots?
Yes, I have.
Click on these 3 dots.
Yes.
What do you have?
Make attendance or make an attendee.
Next to the people, what do you have in this 3 dots?
I have mute participant, pen, remove participant, make an attendee.
So that means you cannot take the attendance. And actually, also I couldn't take the attendance. But what I can say, and what are the suggestions here? The absent is Muhammad Ali bin Isa. I will take this name here, and the remaining are attending. Ben Isa and Abdullah Abdul Kareem. He was with us, Abdullah Abdul Kareem. But he left maybe, Abdullah Abdul Kareem. So these are the two absence for today. But please don't start the meeting as I mentioned. Okay?
Okay.
Okay, thank you.
Doctor?
Yes, please.
Dr. Ryan Awari is here, Doctor, sorry.
Huh?
Ryan Awari.
خلاص Ryan is okay. And these are the those who are not with us now.
Okay.
Muhammad Ali bin Isa and Abdullah Al Abdul Kareem. These are the two absent for today. The others are attending, but unfortunately I couldn't take the attendance. I couldn't download the attendance sheet